You see the screen?
Yes.
Okay, so let's just run over it quickly. This is 2021's first test. So the first question is 11 marks. That's on functions and inverse functions. Okay, and then question 2 is quite disappointing. It's only 15 marks and it's all the trig. But there's 3 questions. Look at that. 15 marks, 3 questions. And then the rest, there's 1, 2 questions on Euclidean geometry. One is 7 marks, the other one 17 marks. Do you want to look at this test? I think it's a... I think so. I think Liam's here. Liam, you're late. Get your mic going, Liam. We are going to do some revision today, because I think we've done all the work that's required for the term. You're writing on the 16th. Is that correct? Okay. Your mic's not working. Right. Let's start with a question. Anyone? Let's start with question 2. Just for fun. We don't have to do it in any specific sequence. I'm just going to copy that out and paste it on a new page. So we're doing some revision, Liam.
Okay.
If you have any other questions, either because of some homework I've sent, or something that you're busy with in school, then you must send it to me. Then we'll do that. Okay, so that's the trick question, not trick. Okay, this is dumb. Let me just get rid of this and just copy out one at a time. Right, first question, 5 marks. If 3 tan A equals 4 and 3 sin B minus 2 equals 0, then determine the value of 10 sin A minus 5 tan square B, where A is between 180 and 360 degrees and B is from 0 to 90. Okay, can anyone tell me what to do? How are you going to approach this? Quick, write it down. Give yourself 20 seconds or 30 seconds to think about it, and then you tell me what to do, what you're planning of doing. Ilani, do you know what to do? I'm not sure.
Not sure.
Okay, if you see these keywords, if, determine, then, or then determine, you are going to do ratios, trig ratios. So basically what we're going to do, we're going to do a system of x. I just want to get another pen. That's a pretty crap pen. You're going to do a system of axes for both of these. So look at this. Let's take that first one, where we have 3 tan A equals 4, and therefore tan A equals 4 divided by 3. And I have to work anywhere between 180 and 360 degrees. So I'm going to be working in the third quadrant, because tan is positive in this quadrant. So my triangle is going to go there. And this is angle A. And tan is opposite over adjacent. And then if I use Pythagoras, then I'm going to do the hypotenuse side is the root of 4 squared plus 3 squared, and that is 5. So that is that triangle sorted. And then this one is 10 sin A. No, it's wrong. It's not sin. It's 3 sin B. 3 sin B minus 2 is 0. So 3 sin B is 2. Sin B is 2 divided by 3. And I'm only allowed to do B between 90 and 100, 0 and 90 degrees. So it's first quadrant. Are you all happy? Exactly know what I've done.
Yes, I'm just writing it down.
And sin is opposite over hypotenuse. So I can get the x value here, which is the root of 3 square minus 2 square. And that is root of 5. So those two drawings, the one was the yellow part, and the other one was the green part. I converted those into two drawings. Got it, Liam?
Yes, sir.
Quickly draw those two drawings, and then we can do the sum. And then you can give me an indication of when we can actually do it. Now it's not difficult, actually.
No, I'm done.
Liam?
Yeah, I got it.
10, but now you can have the answer as well. 10 sin A minus 5 tan B square. Remember, you can write something like tan square A. You can convert that into the square of tan A. Or sin or cos, it doesn't matter. Okay, now 10 and then sin A. I'm going to use the A angle to do sin. I use this reference there. Sin is opposite over hypotenuse minus B of, I use a B triangle for tan. Tan is 2 over root of 5 squared. So that is minus 40 over 5 minus 5 times 4 over 5. So that is minus 8, and those two cancel, minus 4. So I get an answer of negative 12. Just check if I've done it correctly. No mistakes. 40 divided by 5 is 8, negative 8. And then that squared is 4 over 5. 5's cancel, yeah. Okay. That's 5 marks. You'll get marks for these drawings. And a mark for the answer. Or the substitution. I think this probably could have been 6 marks. Not sure. Maybe they didn't even give you a mark here for any of these Pythagoras calculations and rather gave you marks for the substitution there. Okay, next one. So this is called what? A ratio sum, because you build those triangles and you use your different ratios, sin, cos, tan ratios. Okay, and this is a reduction sum. So all the obtuse angles must be made acute. Okay, well, that's not a problem because they're all acute already. Simplify the following. Okay. Can anyone help me with something at least? 4 sin 15 degrees times cos 15 degrees. Okay, now maybe you can help me with those. Cos 45 minus x. What's that? Do you have your identity? What is quite interesting, I don't see in the test that they've got a sheet at the back, do they? Yeah, they'll give you those identities. There we go. Do you want me to copy them out? Do you have them with you?
No.
Yes. Can sir copy them out, please?
Okay. I'll just, this is all the trig ones. So they are giving you this. Okay, it's a bit difficult. I'm just going to reduce the size and you're going to give me an indication if you can actually still see it. Is it too small?
No, it's fine.
That's fine.
Okay, so help me with that. Okay, now I need more space. Let's just redo this. So on top, I have 4 sin 15 times cos 15, unless you can see something I could do with that. I can see something I could do with that. If you can't, it's fine. Then at the bottom, I have cos 45 minus x. And that is cos A minus B. So cos A minus B. Yeah. So that is cos A, cos B, plus sin A, sin B. Yes, I'm going to need a lot of space here. Let me just move this down. Okay, so that's a one term, and then negative or minus. I have sin A minus B. Oh, I forgot to multiply that with cos. So what I'm going to do, I'm going to put this in brackets. And instead of cos at the back, I'm just going to write it in front here because I'm going to multiply it with cos x. And then same here, I'm going to take the sin x and put it in front here. And then I'm going to convert this sin A minus B. You see that? I've just moved this sin x in front of the bracket. So I placed this in brackets and I moved the sin x in front. It's easier to multiply. So now that becomes sin A cos B minus cos A sin B. That's okay. That's a lot of stuff. It's not difficult because I have a triangle for 45-degree angles, which is 1, 1, root 2. So who can tell me what I can do? I'm going to make this small, take this away now because we don't need it now. What can I do with a top bit? I can say 4 is 2 times 2 sin 15 cos 15. Why? I want 2 sin x cos x because that's identity. Okay, at the bottom I have cos x. And then cos 45 is 1 over root 2 cos x. Plus sin 45 is 1 over root 2. And then there's a sin x. And then minus sin x. And I'm going to have exactly the same. Sin 45 is 1 over root 2 cos x. And then I have minus cos 45 is 1 over root 2. And then I multiply that with sin x. Good. All right. Did you understand that top part I did? I just broke up the 4 into 2 times 2. Because now I have an identity on top. I have 2 times, and 2 sin alpha cos alpha is sin 2 alpha, or 215. That's going to become 2 times 15, which is 30 degrees. And I have a triangle for that. Okay, now what? What can I do? Can I not multiply those two brackets?
Yes, you can.
I can multiply those two brackets. Then I have, just want to make sure I'm not doing, I can multiply sin with cos to start off with. That's cos x times sin x. And then I can multiply those brackets. I only have to multiply the first one with the first one and the last one with the last one, because that's the difference of between 2 squares. So 1 over root 2 times 1 over root 2 is a half. And then I have a cos square x. And then the last one is minus half sin square x. Good. So I have 2 sin 30 on top. I have sin x at the bottom times cos x at the bottom. And I'm going to factorize a half out. I have a big problem there. I have a huge problem there. I have cos square minus sin square. That's not an identity. You see that? That is bad news. That is kind of bad news. This is a difficult sum. This is a real difficult sum. Okay. Who can help me? This is a very difficult sum. Okay, so I have a problem. I have cos square x times sin square x, which minus sin half cos square x minus half sin square x, which is not an identity. However, cos square minus sin square is identity. So if I can just multiply that with something, I can force that. So if I could multiply, this is way beyond what you should be able to do, unless I've taken a very long route. If I multiply that with 4 on top of 4, I don't have to do 4 on top of 4. I can just do 2 on top of 2. 2 on 2. Okay, let me do that in a second. Just write that down. Half cos square x minus half sin square x. So on top, I will have 4 sin 30. And at the bottom, I'm just going to multiply the 2 with each one of those. I'm going to keep the sin x times cos x. And I'm going to multiply that half with half. A half with 2, I get cos square x, then minus sin square x. But this is not going to help me anyway. I need to get rid of that, and that's probably not going to help me at all. That is a big problem. Let's just check if I haven't written down something wrong. No, I haven't. I haven't. That's correct. That is correct. Everything is correct. Top one, we can actually get a value for. The bottom one, we can't get a value for. The problem is I can't factorize that either at the bottom. Wow, this is kind of interesting. What do you do in the exam when this happens? When you get to a point where you realize you've overshot your 6 marks anyway, so you've missed something, something small maybe. I can't see anything that we've missed. So what are you going to physically do then? Redo something. Take another route or redo the sum. What I would normally do is do the following sum. Forget about this one. Do the following. And then we come back at this one. You redo the whole sum. You redo the whole sum. Where can we take another route? So if we redo
You
this
can multiply
at the
You
bottom.
can you can multiply that into the brackets.
Yes, that is we just factorized that, but we can multiply back into that bracket. So in other words, you can say, look, we don't have to do this. So let's get rid of this. And we can multiply that bottom part out. So I'm going to multiply the cos there. Then I get 1 over root 2 cos square x. And then I'm going to multiply the other one, which is 1 over root 2. Then I get sin x times cos x. So I've multiplied there and there. Very good, Ilani. And then I multiply there. I get negative 1 over root 2 sin x cos x. This is much easier. And then I multiply there. I get positive 1 over root 2 sin square x. Now these two are the same and they cancel one another. Okay, good. Very good. On top, I'll have 2 sin 30. At the bottom, I have what? I'm going to factorize out of those two terms. I'm going to factorize 1 over root 2. Then I get cos square x plus sin square x. And that's 1. So I have 2 and sin of 30 is a half. I just need to draw this triangle to prove it. 1, 2, root 3. So sin of 30 is a half. And then I have 1 over root 2 times 1. And that is root 2. So that was much easier than what we tried. So sometimes when you just stop the sum, start fresh and just take another route, everything becomes easier. We made a mistake somewhere, obviously. We would have, if we didn't make a mistake, we also would have gotten here. But somewhere we made a multiplication mistake. Good. So I want to show you what the type of sums, the difficulty of the sums that you're going to get in the test. Okay, we've got one trig sum left, and then we're going to go to functions and inverses. The trigs, three sums, 15 marks. This one is 4 marks. Okay, this is a general solution with a solution, with the actual solution added to it. Okay, let's go. We need that little page as well. Right, here we go. I'm just going to move it to the bottom. Can anyone help me with something there? Can we change one of those two things? You can't factorize sin out because you have a 2x and an x and they're not the same. It's like a y and a z. So the only thing I can see is to convert that sin 2x into its double angle identity, which is 2 sin x cos x and then plus 4 sin x equal 0. Are you with me, Liam?
Yes, sir.
You can divide with 2 if you want to. It's not necessary. You can, or you can just factorize 2 sin x out. Then I get cos x plus 2 is 0. That's not difficult. That's why it's only 4 marks. Because now, out of that, I'm going to delete this now. We don't need that. Out of that, 2 sin x must be 0 or cos x must be negative 2. This one is not applicable. Why? If you do shift cos negative 2, you get error. It can't be less than negative 1 or more than positive 1. So in this one, sin x equals 0. If you know what the sin graph looks like, you know exactly where it's 0. It's 0 degrees, 180 degrees, and 360 degrees. Shift sin 0 is just 0. So x is 0 degrees plus 360 times k. K element z. That's my first quadrant answer. Or x equals 180 minus 0, or just 180, plus 360 times k, k element z. Those are my two general solutions. But they want to solve between negative 180 and 180. What does that square bracket mean? Does that include or exclude? It includes. So it's the same as x smaller or equal than 180, larger or equal than negative 180. So let's find those solutions. I can have a 0 degrees if k is 0. I can have, if k is 0 at the bottom one, I can have 180 degrees. If k is minus 1 in the bottom one, I can have negative 180 degrees. Those are the only solutions I can get. So I want to make sure square bracket means including. Yes. Because that rounded bracket means excluding. And square is including. So it includes negative 180 and 180. This wasn't too difficult, was it? This one was easy. Right. Okay, let me ask you what you want to do. Do you actually want to do the functions and inverses for 11 marks, or do you want to do a Euclidean geometry example?
You can do Euclidean geometry.
Okay. Right, look at this. 3.1. In the diagram below, K, L, M, N are points on the circle with center O. Tn is a tangent to the circle. Prove the statement that LMN, that angle, is equal to K. Now, this is a statement. In other words, what? This is your statement or your theorem of what? Tangent chord, your tangent chord statement. This you have to learn. This was something you learned from grade 11. Can you remember that? You had about 5 or so statements that you had to learn. Could you remember that, Liam?
Yes, sir.
So this is utterly unfair. Can you remember to do that statement? No, you probably forgot. So what they did here, they took any of the statements from grade 11. So you need to actually be aware and go back and make sure that you can do those statements. There's a angle at the midpoint is twice the angle at the circumference. That's one statement. This is the other statement. Okay, so go and look at your statements again. Okay, how much is this? Okay. All right, let's just copy this. So we're not going to do the statement. That's theory. You have to go and learn the theory. It's not a sum. Okay, I'll give you a minute now to copy this. I just want to paste that on a different page. We can't work like this. 7 marks. Name of the reasons 4 other angles equaling x. Okay, so now if you look at this, do you want to make this drawing or just look on to the one that I'm doing?
I'll just look.
Liam, I'll give you time to do the drawing if you want to. Liam, wake up.
Yeah, yes.
What do you want to do? Do the drawing, yes or no?
Yes, drawing.
Okay, take 2 minutes, do the drawing. Someone's already played with this. I can see markings on the drawing. So they tell you that G2 is X, and we need to find 4 other angles equaling X with reasons. That's awesome, because that's 7 marks. So Ilani, you can start trying some of them. There's also a tangent, ED, and BH equals BD. That's on the drawing. You tell me when you finished, Liam. So this yellow line here is a tangent.
Okay.
Good. So G2 is X. Can anyone find another angle equaling X? We need to get 4. What about D3? D3 is X, and there is angles on circle segment. No. Do you use circle segment or do you use same circle segment? Ilani?
Same.
Ilani?
I'm not sure.
Okay.
It's,
Angles on the same
it's-
segment or same circle segment. I've just got angles on circle segment in my. Okay, good. Right, so those two are both
Mine,
X. Yes. on
mine
the-
says same circle segment.
So angles on same circle segment. Good. Right, another one. Come. It's your turn. Come, Liam. It's not that difficult. The second one is easy still. What about
Okay.
H? This whole angle H here. H1 and 2. Why is that one X? Well, BH is the same length as BD. So that's what? What? Angles, angles on equal sides, no? Good, next one. So this is X. Can come, anyone? Look, we have a tangent, we have a quadrilateral or cyclic quad. Look what you can do with a cyclic quad. There's my cyclic quad. See if you can find any other, like an exterior angle or something. G.
Q1 or G1.
Okay. Yeah. Yeah, G1. Okay, I just used G4, but you can use G1. G1 is X. That's exterior angle. Exterior angles of a. How do you make a cyclic quad shorthand? Is it just SQ? What is shorthand for a cyclic quad? Or do you write cyclic quad?
I just write cyclic word.
Okay. So that one is X, that's correct. And then G4 is also X. Is that correct? Yes. Why? Opposite angles. Vertically opposite angles. Vertically opposite angles. Right, these are 4 angles equaling X. I wonder if there's a fifth. Okay. Prove that this is a grade 11 sum. Prove that GKDE, GKDE. Prove that that thing is a cyclic quad. Well, is it really? Yeah, it's easy. It's going to enlarge it a bit. Well, there's only 2 ways to really prove that something is a cyclic quad, and that is if there's an exterior angle equaling one interior angle, then, or if the interior angles are supplementary, in other words, equal to 180 degrees. So what I can see here is that if this red thing is a cyclic quad, if I can just get that angle, I've got this one now as X, G2. If I can just get that angle as X as well, then it's done. I haven't used the tangent yet. So if I run down that tangent from E to D and up this chord here, then this angle here is the same as that one. So I can say that EDK equals H1 and 2. It's tangent chord statement. But it's the opposite. What's it called? Inverted. Do you use inverted tangent chord statement, or do you use line between circle and chord, something like that? I know that in Afrikaans we use omgekeerde raaklyn koordstelling, but I'm not sure if you convert that into inverse tangent chord statement. What do you use for that? Because it's not, they haven't given you an angle. You have the exterior angle as X. So that one must also be X. So
I'm not sure.
Okay, let me quickly find that. I'm actually interested in how they do that in English as well. Because in Afrikaans, we just use the opposite of the one. In other words, I'm not starting with the angle between the tangent and chord. I'm starting with the angle that's on the segment of the circle. So it's just the opposite. So I need to find the English one. Does anyone know that? Come, Liam.
I think it's the second one, that line, whatever you were saying, tangent.
Yeah, I'll get it in a second. No, this is just examples. And I have only Afrikaans ones here. That's pity. Yeah. I don't have that. I don't find that in any of my that inverse one.
I didn't see it in my textbook either.
I don't have that in my, I only have that in Afrikaans one. They don't have it in the English one. So angle, yeah, tangent chord statement would be correct then. So now I'm 100% sure. Okay, you can use the following: converse. Converse tangent chord statement, that's one option. Or you can say angle between line and chord. No, this one isn't correct. No, this one isn't correct. No, it isn't correct. Let me explain this. If you want to prove that that is a tangent and those two angles are the same, then you can use converse tangent chord statement or line between chord and line between circle and chord. This one you can still use tangent chord statement. You can still use it because it's still a tangent. You don't have to prove it's a tangent. It is a tangent. Okay, so that's fine. It's not that difficult. That's why it's not common to find that one, because you almost never prove that something is a tangent. You always use a tangent. So if you use a tangent, so I can use tangent chord statement. So if that one is X, so D1, EDK is, that one is X there. So use another color, black. That one is X there. And that exterior angle is X. So that thing is a cyclic quad. So GKDE, therefore GKDE is a cyclic quad. Exterior angle of quad. So the exterior angle of that quad equals the interior angle. Yeah. Okay, good. All right. Is that fine? So that we can conclude it's a cyclic quad. This was just grade 11 work, no grade 12 work added to this. So this is just a statement you have to learn and then something else. Okay, let's add some grade 12 work. Just want to make that bigger. We're almost finished. Seven marks. Right. Quickly make a drawing there. Copy that. EF is parallel to AGC. That's the only parallel lines they're giving us. That one and that one's parallel. Quickly make that drawing. Tell me when you're finished.
Yeah.
I'm done too.
Are you finished, Ilani?
Yes.
So I'm going to do AH over FH is 2x over 3x. You don't have to put the x's in there now, but I'm doing it. So AH is 2x over HF, which is 3x. And then it also give us the following. AG over GB equaling 1y over 4y. AG, y over GB. Now GB is 4. Why do I have a K there? I mean, really? 4y. They want to know what is CB or CF over FB. So basically, they want you to work in this green triangle at the end of the day. this green one. So let's start with the x's and we move over to another triangle. So now what you need to do, you need to be able to visualize this triangle because this triangle has those two parallel lines in it and it's got the AH and the HF in. So AH over HF equals AG over GE equals 2x over 3x. And my reason here is what? Line parallel to one side of triangle now.
Yes.
Okay, I'm filling that in. This is a 2x and this is a 3x. So now I've got those ratio. That ratio is just really important. The ratio is 1y equals 2x. That 1y equals 2x. That's my ratio, which I'm going to use to move between my x's and y's. Okay, now I just need to get the EB part. Can anyone see the length of EB? EB equals GB minus GE. And that is 4y minus 3x. So I've got the length of EB. So now I can use this green triangle that I wanted to use right at the beginning. Because now I can say, let's write in red, that CF over FB, CF over FB is GE over EB equals 3x over 4y minus 3x. And my reason there is also line parallel one side triangle. You can name the triangle if you want to, like CGB. Okay, now I've got that. So therefore, CF over FB equals 3x. And then y is just 2x. So that's 4 times 2x minus 3x. And that is 3x. And that's 8 minus 3, which is 5. And then that ratio is 3 over 5. You didn't have to use the x's. You can just use y's if you want to. But I just standard put in the x's so you don't get confused with lengths and unknowns. This is easier than the one you had in your assignment. Do you agree?
Yes.
Okay, now Liam disappeared. Wow, where is Liam? Liam's gone. Okay, let's just look. We've got 15 minutes left. Just make sure that the inverse graphs is not a nightmare. They can be somewhat threatening, actually. Okay, let's do that. What type of graph is that fx?
Inverse graph.
It's fx is that's an exponential graph, isn't it?
I think so.
That doesn't sound good, Delani. Think so. So that graph you can rewrite. I don't like that method of writing it. I always write the f graph is y equals 1 over 5x. And that's a exponential graph, which actually slopes down. So it goes like that. If I make x 0, I get the y-intercept, which is 1. If I put in negative 1 as an x value, I get 5 as a y value. So there's the graph. So I just quickly draw it. So that's f. So now 1.1. What is the equation of f to the power of minus 1? Well, it's going to be a log graph, isn't it? That is log AX, that's your standard log graph. The inverse of an exponential graph is a log graph. I just need to get the A value. Well, the A value is a fifth. Would you be able to do this? What we've done just now.
Yes.
Okay, so that's 1 mark. Bang. Then 1.2, 4 marks. Sketch F, we've got it already, and the inverse on the same set of axes given on a diagram sheet. Okay, well, we don't have a diagram sheet with us. There's the F1. The inverse you've actually learned. It's just this one. So this x-intercept will be 1. And the x and y coordinates will flip around. And we will have this line here. A little dotted line going through there and the origin. And that line is y equals x. And there's your graphs. That's 4 marks. Eh? Just remember to have a y-axis and an x-axis. That's not difficult. Good. We're on our way. So that's done. 1.3. What is the domain of f to the power of -1? Domain is what? X values, isn't it?
Yes.
So the domain is, if I look at that red graph, the x values is always larger than 0. Is that true? Yes. It doesn't touch 0 and it's real. It exists. So on the red graph, the x values are always larger than 0. So this was 1.3. Why is it 2 marks? Okay. Now, let's just get this done out of the way. Now look at 1.4. For which values of x will fx times f to the power of -x be larger or equal than 0? How would I get larger or equal than 0? Well, the first step is if both graphs are positives, positive y values. Positive times a positive is larger or equal than 0. So when is both graphs above the x-axis at the same time? Well, anything from 0 on, just after 0 forward, up till 1, because the minute we hit the x value of 1, the red graphs go underneath the lines, go negative values. So I can say the x values are larger than 0 or smaller than equal to 1. Can you see that? It's this little section here. In this
Yes.
yellow section, both graphs have positive values or is above the x-axis. Anything lower than that, I don't even have a red graph. And then anything after 1, the red graph is negative. And there's no scenario where when both graphs are negative. So this is the only place. And you're allowed to add that we are talking about real values. So that's done. And now they're trying to give something difficult, probably 1.5. Give the range, okay? Range is y values of gx. Gx isn't even there. So gx is the following. Gx is minus f of x minus 3. What the hell is that? What is minus fx? Minus fx will look something like that. Like what? Do you have an idea?
No, not really.
Okay. Let me just get this bigger. If you don't know what to do, then with graphs, we always try and go visual. Come. This one has now blocked my screen. Just want to make this thing bigger, if possible. Okay, so look at the fx again, the black graph. That's just f of x. Now minus f of x is when that thing just flips around. There we go. And that value becomes, for instance, -1 and -5. Anyway, so that is negative f of x. So all the y values change sign from positive to negative. And then if I add another -3, I'm actually pushing that graph down. So it had a -1 intercept. So if I move that graph 3 units down, it would look something like this. So let me just copy that. It would look something like this. Where my y-intercept is now -4. It will also go that way. Okay, and this coordinate here will be -1 and -8. So now what's the question? What is the range? There will be a system of asymptote there of y equaling -3. So the range, that's the y values, isn't it?
Yes.
That y will always be smaller than -3, and y will be real numbers. So that all my y values will always be smaller than -3. Does that make sense?
Yeah.
We've done this whole paper now in an hour, less than an hour. Except we didn't do that. This is quite worrying to me. The fact that they're expecting you to do a grade 11 statement. There's some grade 12 statements and grade 11 statements that you'll have to look at for the testing. Okay, Lani, what we'll do next week, I'll just grab another paper and we'll do revision. And it's
Okay.
time that you start working on your own as well, so that you have more questions. Okay,
Okay.
keep on.
Thank you, you too.
Bye.